Good morning, everyone. Today, we're embarking on a journey to explore the architecture of genius, Florence, Leonardo, and the profound synthesis of art, science, and nature. We'll delve into Leonardo da Vinci's unique empirical method, which he termed saper vedere, or knowing how to see. This approach allowed him to dissolve the traditional boundaries between disparate disciplines, using the vibrant city of Florence as his living laboratory. Florence, in the mid-15th century, was truly an incubator of innovation and the economic engine of the Renaissance. The immense wealth generated by the powerful wool guilds and the banking prowess of the Medici family provided the capital necessary for radical new ideas to flourish. Consider the gold florin, often called the dollar of the Middle Ages, a stable international currency that facilitated trade across the known world, fueling this economic engine. A significant catalyst for intellectual growth was the fall of Constantinople in 1453, which led to a massive influx of Greek scholars and invaluable manuscripts into Italy. This created a highly competitive market, where a dense concentration of wealth spurred fierce competition for artistic and scientific innovation, turning Florence into a crucible of genius. Leonardo's education didn't happen in a traditional university setting but rather in the polymath laboratory of Verrocchio's workshop, a place where art and engineering were not separate but intrinsically linked. Here, the artist and the engineer were one and the same. He learned metallurgy and mechanics, mastering the casting of bronze, and understanding principles of lifting weights, levers, and cranes. Chemistry was also a key part of his training, involving the preparation of paints, understanding minerals, and their chemical properties. And, critically, geometry was taught not just as mathematics, but as a rule of optics, essential for mastering perspective in art. Central to Leonardo's genius was his philosophy of saper vedere, or knowing how to see. Denied a classical education in Latin and Greek, Leonardo famously described himself as an homo senza letter, an unlettered man. Yet, this propelled him to reject dogma in favor of relentless empirical observation. He believed nature always progresses from the simple to the complex, and from the particular to the universal. He criticized philosophers for proceeding in the opposite direction, calling it a very great error. His method was clear: test everything. This is evident in his codices, thousands of pages of notes, often written in mirror script, from right to left, a technique he likely used to protect his intellectual property. His overarching method involved dividing nature into its smallest segments to truly understand the whole, meticulously measuring, dissecting, and testing everything he observed. Leonardo's Geometry of the Human Form is a visual manifesto of Cosmographia del Minor Mondo, the belief that man is a miniature reflection of the universe. In his iconic Vitruvian Man, the circle represents the cosmic or divine, while the square represents the earthly or physical realm. At the center of this composition is the navel, which he saw as the central point of biological configuration. Leonardo, through his own extensive measurements, actually corrected Vitruvius's original ratios, noting that a man's arm span is nearly equal to his height, demonstrating his commitment to empirical observation even in classical works. For Leonardo, anatomy was an indispensable instrument of art, a means to uncover what he called the moti mentali, the movements of the mind, or the internal expressions of emotion. He famously dissected over 30 corpses, not out of morbid curiosity, but to understand the intricate machinery beneath the skin. He firmly believed that art could not truly capture the human form without a deep understanding of the body's mechanics. Through his dissections, he made several key discoveries: the first accurate description of the spine's double S shape, correctly identifying the four-chambered structure of the heart, thus correcting previous errors by Galen, and creating the first accurate depiction of a human fetus within the womb. Let's turn to the engineering of a smile, specifically the Mona Lisa's world-renowned elusive expression. This is a triumph of neuroanatomy. Leonardo dissected facial muscles to truly distinguish between voluntary movement and genuine emotion, what we now call the Duchenne smile. His technical insights were revolutionary. He understood peripheral vision, blurring the corners of the mouth. When you look directly at the smile, it seems to vanish. But when viewed peripherally, shadows make it appear to flicker, creating that enigmatic quality. Anatomically, he discovered it's impossible to pucker the upper lip alone. The brain coordinates complex muscle groups to produce a natural smile, a detail he masterfully incorporated. Leonardo also mastered the physics of light through his revolutionary painting technique, sfumato, a term meaning vanished like smoke. He observed that nature contains no sharp lines, and he developed sfumato to perfectly mimic how light interacts with air and moisture. The technique involved microglazing, applying 20 to 40 layers of ultra-thin glazes, some only micrometers thick, to create seamless transitions between colors and tones. He also employed atmospheric perspective, painting distant mountains in soft blues and grays to mimic Rayleigh scattering, the phenomenon of light scattering by particles in the atmosphere, making distant objects appear lighter and bluer. Leonardo viewed the Earth itself as a living body, referring to it as the macrocosm, with water acting as its lifeblood. He famously rejected the biblical flood theory, instead favoring geological evidence to explain natural phenomena. His scientific observations were profound. He studied hydrodynamics, noting that water spirals follow the same mathematical geometry as curling hair. In tectonics, he recognized that marine fossils found on mountaintops proved that land was once seabed that had shifted upwards over eons. And remarkably, he theorized planet shine, deducing that the moon's faint glow was sunlight reflecting off Earth's oceans, long before it was scientifically confirmed. Leonardo's vision extended far into the future, as exemplified by his Golden Horn proposal, from 1502. He proposed a remarkable 280-meter single-span bridge across the Bosphorus. At the time, it was rejected as impossible, yet in 2019, MIT researchers validated his design, confirming its structural integrity. His engineering analysis highlighted several key aspects. The geometry involved a flattened arch with splayed abutments. The physics relied solely on compression and gravity, meaning no mortar or fasteners were required. The verdict from modern analysis confirmed it would be structurally sound and stable, even against earthquakes, showcasing his extraordinary foresight. Leonardo's relentless study of flight evolved from simple biomimicry to complex aerodynamics. He observed birds, developing extensive wing studies. His evolution phases began with ornithopters, machines designed with flapping wings. These failed due to insufficient human muscle power-to-weight ratio. He then progressed to Phase 2 gliders with fixed wings, dependent on air currents. This laid the fundamental basis of modern aviation. His legacy also includes the aerial screw, a concept for a helicopter, and the pyramid parachute, which was successfully tested in 2000, proving the ingenuity of his designs centuries later. To secure patronage from powerful rulers like Sforza and Borgia, Leonardo strategically marketed himself as a pragmatic military engineer. His key military inventions were truly ahead of their time. He designed what we recognize as an early version of the tank, an armored vehicle with omnidirectional cannons, famously designed with a deliberate gear flaw to prevent theft of his intellectual property. He also conceived of a steam cannon, a precursor to steam power that utilized superheated water. And, incredibly, he designed a diving suit made of bamboo and pigskin, intended for attacking enemy ships from below, demonstrating his innovative thinking across diverse fields. Florence today stands as a testament to this incredible era, a living museum of innovation. The city maintains a global reputation for high-quality artisanship and fashion, continuing the legacy of its Renaissance guilds. Key landmarks endure: Brunelleschi's magnificent Duomo, still the largest brick dome in the world, and the Uffizi Gallery, housing countless masterpieces from the era. Beyond its historical treasures, Florence remains a hub for modern industry, particularly for luxury fashion brands like Gucci and Ferragamo, and for its renowned leather guilds, proving that the spirit of innovation and craftsmanship lives on. Leonardo da Vinci is often considered the grandfather of systems thinking. His work emphatically proves that true innovation requires the integration of science, technology, engineering, arts, and mathematics, moving us from STEM to STEAM. His approach has profound modern applications. Think of robotic surgery, where anatomical maps guide precision instruments, much like Leonardo's anatomical studies informed his art. Biomimicry, designing drones and propulsion systems inspired by bird and fluid dynamics, directly echoes his flight studies. Most importantly, his legacy underscores the necessity of cultivating a complete mind in education to solve the increasingly complex problems of our world. Our guiding principle today, and a timeless lesson from Leonardo da Vinci himself, is that practice must always be founded on sound theory. This encapsulates his entire approach to life and learning. Observe closely, test everything, and always remember that everything connects to everything else. Thank you.